Well, hi, it's Keith from Sunsynk. I've done lots of training manuals and stuff on the web, but I've just tried to do another one. This one is just sort of a complete mini course. It's a crash course on understanding our inverter. You need to use this in conjunction with the training manual. I've just produced a training manual. So if you download the training manual and then read it through with me, and I can explain a little bit more. So it's a very useful document. We also suggest download the latest instruction manual. So you've got the instruction manual and the training manual. And this covers sort of all our inverters sort of from 3.5 kilowatts right up into, well, very soon the 10 kilowatt three phase, and obviously using multi-inverters into many large applications. Okay, start off. What is a hybrid inverter? Well, a hybrid by its pure definition means a mixture of two technologies. So hybrid's being used for many things. You can have a hybrid plant, you can have a hybrid car. So it's just two technologies. Hybrid inverter can be a very simple hybrid inverter. It can be simple as much as it can be a charger circuit. So basically you can have a standard off-grid inverter, a normal off-grid inverter. You can use a changeover relay. And so when your battery is charged, clonk, the relay changes over and it draws the power from the inverter. And that's been around for a long time. And that's many sort of so-called hybrid inverters operate this way. They're a very simple technology. They're very different to the Sunsynk machine, and I'll explain a little bit more why, but they're a very simple machine. But they work and they can do certain jobs and certain applications. Most of the cheaper inverters tend to be MOSFET based. There's nothing wrong with MOSFET based inverters. It's just that you have to be very careful with MOSFET based, because if you get flywheel effect from certain types of products, so for example, if a motor is spinning like an electric drill, something can create a lot of eddy currents and back EMF, and then the flywheel can reverse the power back into the inverter. These huge currents can pop components very easily. And it does, and this is a problem with many sorts of MOSFET inverters. You know, MOSFET inverters are fine. They're obviously suitable, and they're obviously hit price points, so they're very important because of the price point. But be aware, the Sunsynk inverter is a driver type inverter. It's an IGBT-based insulated gate bipolar transistor. The beauty of IGBT is it's very powerful and very strong, and it can withstand sort of large eddy currents and back EMFs and stuff. So if you see on the first page, on page 1, you see sort of a simple drawing of a simple hybrid inverter. And as I said, it's just an off-grid inverter and a battery. It's really, really simple. So there are many types of hybrid inverter. So you've got the very basic type of inverter, which these are normally high frequency inverter. You do have some low frequency and high frequency inverters. Before I explain it, low frequency use a big transformer. High frequency is a switch mode, and they use a smaller transformer. So basically you have some sort of conversion, takes the frequency very high, and then it drops it back down to the desired frequency. A low frequency operates everything at the 50 or 60 hertz, whatever system you're operating in. And low frequency tend to have a huge transformer in. They're very heavy. It's the downside, really heavy. We had one in our office, an 8 kilowatt. It was, well, I can show you the video. I was trying to get it back off the wall one time. It was very difficult and very heavy. And not much fun to install. And if you have a problem, my God, trying to get the thing off the wall is really difficult. So most of the market tend to go towards high frequency now, and the main reason is weight. I'm not opposed to low frequency, and low frequency is fine. And just repeating myself, it is a weight issue, and that's the main thing. So you talk about basic, very basic high frequency inverter. These are the sorts of things you see in car shops, and these small inverters, and a lot of people use them everywhere. If you're camping, you might have one, and a lot of small houses may use them. You can't generally use them for very long. They have a sort of finite life, maybe 1,000 hours usage. So you've got to be a little bit careful on that, but they're okay for standby, they're okay for an emergency, fine for camping. Obviously different grades, different qualities. There's two different types. Some of them are self-oscillating, and some of them use CPU, some of them use multi-CPU. So it depends about how it works. Going to the next one, you'll see on the document, we call basic high frequency charger inverter. It's very similar to the ordinary inverter, except there's a battery charger in it. Most of these battery chargers are a separate charger circuit on the PCB. So you'll see, if you look at the PCB, you'll see the inverter, and then you'll see maybe have a PWM or an mppt circuit. and then you've got a charger circuit. So you clearly see, if you look at the PCB, they're very separate sections. And on this type of inverter, you have the power comes in, it goes through the DC, is then converted to an AC, a high frequency AC. It passes through a transformer. The transformer is quite small because the high frequency transformers are much smaller, and it will pass through a transformer to bring it up to the higher voltage. Use a couple of capacitors to smooth it down, and then use another stage of MOSFETs that are then converted to the AC power. And you'll see that. And then separately on the circuit, you'll see the mppt, the maximum peak power transfer device, or a PWM, and that's used for charging a battery. And you'll see the changeover contact, which is a relay. Main problem with this type of inverter, or all of this type of inverter, is if you need 5 kilowatts of power, you need a 5 kilowatt inverter. If you've got a peak demand of 10 kilowatt, you need a 10 kilowatt inverter. Most houses have a huge peak demand, so say 20 or 30 or 40 kilowatt. Now you then need a 40 kilowatt inverter, which is huge. It's a huge piece of kit. The thing is, if you're using an AC coupled device, then there are advantages where you don't need that, and you can use a much smaller inverter, and the peaks the grid can take care of, or your genset, in various ways. So it's a little bit less, you can downsize, you don't need such a big inverter. Then we can go on to sort of what they call multi-mode hybrid inverter. So these are sort of a larger version of the above, really. These are bigger ones, similar type of thing. They've got some communication, maybe work with BMSs, and most of them again are MOSFET based, but these are generally known as multi-mode inverters. And you'll have some basic or some sophisticated battery management system that can control the lithium batteries. Now they are all within one group, and all those type of inverters, you're limited by the maximum power of the inverter as is your peak power. So you have to be very careful about setting your system. But then you move on to what they call AC coupled inverter, and you've seen them before. An AC coupled inverter is a device which is like a grid tied inverter, or a string inverter as the Americans call it. A string inverter, it sits on just one connection, and it will allow the power to pass from the solar panel onto the grid and use the power, or it will export the power depending on the type of string inverter you've got. Sort of AC coupled inverter works that way. And most of them have some sort of a device that blocks the power. Some of them don't, but most of them have a device called a CT coil, a current transformer. So CT stands for current transformer. Most of them have a current transformer device, and that blocks the power going back into the AC. And by blocking it back, you only use what you need, and the extra power will then go into your batteries. So these are sort of referred to as sort of AC coupled. Generally, AC coupled are much better, because you don't, if you fit, for example, a 5 kilowatt, but you may have a peak demand of 20 kilowatt, the difference will be drawn from the grid. So it's much better, and you don't have to have such a big inverter, and your whole power is not powered through the inverter. And then the other thing is a lot of some of these AC coupled devices, most of them don't, they have an inverter circuit. You will have a charger circuit, a separate charger circuit. So you have a battery charger, an inverter, a battery charger, MPPT. They might actually all be separate components depending on the type of inverter. So some inverters might actually have a whole host of separate components. Some of them might be all in one. Then sort of find number 5, as the Australians refer to it as super inverter. Well, the Sunsynk, and maybe I'm biased, is a super inverter. It's a bi-directional driver type inverter. If you look at the very large inverters, the sort of Schneider and the sort of ABB, the top brands inverter, and these huge mainframe inverters, these are what they call driver type, where you have a separate computer that will operate, or they will operate the, it's not a gate because they use transistors, they call it the base of the IGBT. So it'll operate the transistor, and it will control the transistor from basically a computer. So the board is the driver. So you have the board, which is the computer, is the driver. You have the IGBTs, which do the switching. You'll have a separate power supply board. The separate power supply board just basically powers the computer and powers the motherboard. You'll have a relay board, and you'll have lots of other different pieces on it. It's called a driver type inverter. The Sunsynk is an all-in-one driver type inverter. Everything, it's a complete unit. So it's actually got built on board. It's got all the components. But one major point about it is a bidirectional inverter. The inverter can reverse. It's one of the benefits of using IGBT. It can be used as a charger or an inverter. So the advantage of using it as a charger is you can basically, if you've got an 8,000 watt inverter, you've also got an 8,000 watt battery charger, subject of course to your size of your batteries and the C rating of your battery. But you've got this huge battery charger and this huge inverter, and it's all in one because you don't need separate things. The whole machine reverses and becomes a charger, and then it becomes, because if you've got power coming in from the AC, then you're going to use your AC and you can charge the batteries. Separately, the MPPTs will charge the batteries, and the MPPTs do work separately to the main charger circuit, which is the inverter. So you've got the MPPTs, which will charge the battery, and so you've got two different things going on. So this is sort of giving you sort of a basic idea. If you go into the documents I supplied, you can see how it works and how the AC coupled, because with an AC coupled inverter, you only have one wire. You have your AC in and you're out. It's a single connection. Your load connection is what we call a UPS, uninterruptible power supply. Many people would refer it to essentials, non-essentials. So your heavy loads, which is your non-essentials, your air conditioners, you can connect to your grid side, your grid connection. You can still power them from the sunshine, not a problem. But the other side, you connect to your load side, which is your essentials. So you've got both. If you have a power outage and the power goes down, you will lose the grid because you have to, because the anti-islanding, it's a legal requirement, and the inverter will shut down for a period and then eventually restart itself once the grid is present. The load side will click and it will continue as a UPS. But you don't want to put something too heavy, depending on the size of your inverter and depending on don't put your whole house through the UPS side because it's pointless. Because if you have you're going to flatten your batteries and you're going to maybe overload the inverter. So just put your essentials, put your security lighting, maybe an air conditioner, one air conditioner, put your electrical sockets, your TV. So put all your essentials, of course, all your lighting, we'll go through it. So put all your essentials, and if you do have a power out, click, it will continue and you don't lose any loads of power, but you'll lose some of the inverters. I've given a diagram just showing how the things switch in and out, and I'll explain a little bit more because we have actually 3 ports. So we have obviously the mains, the grid port, we have the load, which is the UPS, and also we have the auxiliary or a gem port, and I can explain a little bit more about it. So let's go forward. Understand how the inverter, let's look at the flow of the inverter. So first of all, sun is shining. We'll start off with, we've got solar panel. You can actually wire the inverter without solar panel if you want to. So we start off, sun shines, goes through the MPPT, maximum peak power tracker, or whatever you want to call it, but it's a tracking device. And so basically it allows the solar panel to work at its optimum. It also allows us to run at high voltages, so much less loss. And MPPTs now are generally used throughout the whole industry. And you can run your cables much higher voltages and reduce your losses and stuff. So it's much a better thing to do. So your power comes through the MPPT. If you've got 2 MPPTs, the machine then combines both MPPTs together. So you've then got your power. You have a choice what you want to do with the power. Right, you can charge your batteries, prioritize to charge your batteries. Personally, I will always charge the batteries first because that's your lifeblood. Secondly, you can use the power. You can prioritize to load. So my view is, personally, I would transfer the power to batteries, then to load. Common question people often ask, well, the sun is shining and I'm still using electricity at my house. What's going wrong? Because the solar is prioritizing to charge the batteries first. And you may still be using power at the house. Often question, if you prioritize it to load, then you power the load and any surplus from the load will go to your battery. So depending on whereabouts in the world you are, generally I would charge the batteries and then use the load, but depending on where you are. As I say, if you're in the UK, for example, you may choose to power the load and the surplus that you don't use on the load will go to the battery. because the battery is just a bonus. It's a benefit. It gives you some power at night. Whereas, for example, in some Southern African countries, it's a necessity, because if you're going to get a power outage, load shedding, and the power out, you want those batteries at maximum power. So I would always prioritize the battery. And by clicking the bar chart on the inverter front, you can see clearly there's a very nice flow chart, and it shows you exactly what's going on. It's beautiful, and you can click it and it will show a very clear thing what's going on. So your power is going to your battery or going to your inverter, and then you decide what it's going to do. You can then, we have a sort of control or a system mode device. It's the controller, and that actually decides what it's going to do. You may have an export tariff which you'll choose to export it, but generally most places in the world, with the exception where I live, Hong Kong, which has an absolutely ridiculous export tariff. You'd never believe how much they give you to export power. But I don't come across many other countries like that. So most of the time you don't want to export, you want to save the power, because the fact that, quite frankly, the cost of electricity, if you have to buy it, will cost you more than what you'll get export if you get anything for export. Some will give you the same, but you're better to save the power. So use what you need to use, save what you need to save. You can then divert, you choose how you want to use the power. So you can then use what you're generating from the solar, you can just have it onto the load, or you can use it on the house, what we call a house. The house is basically the grid side. So depending on the size of the array that you've got, then you can choose where you want to use the power. So it's a very nice, if you just click, as I say, on the bar chart, it shows you very, very simple. I'll go through further onto the video how to use the power and the benefits of it. Now, if I talk rather fast, then I suggest just stop the video and maybe review and consider a little bit more, but let me carry on. Okay, mounting the inverter. Right, you've got the inverter out of the box, you've read the instructions, you're a qualified electrical engineer, or you're basically competent to install it, and you have the necessary local licenses, because many countries require a local license to do this type of installation. So you need to mount the inverter. You must install the inverter where it is reasonably cool. Don't put it into a container painted black, for goodness sake, it will just overheat. The inverter doesn't have an air conditioning unit. It has fans that will switch on when it needs, and it will blow air across the fans. But if you're in an environment that's absolutely roasting hot, and the hot air is going to blow across the fans, there's no way to cool it. It's impossible. So think about where you fit the inverter, and also don't put it in direct sunshine. Direct sunshine can damage LCDs. It's a known fact, and ours is a really nice full color LCD, and if you've got direct sunshine on the LCD, after a number of years, it can damage the LCD. This is just nothing we can do about it. It's a general fact. It does happen. So mount it in a reasonably cool place. If you've got a problem and it's a very hot area, and you may have to consider a small air conditioning unit, but generally it shouldn't be a problem. So you need to look at that. One of the common questions I keep getting asked is mounting the inverter, and what's the distance? Ideally 1 meter apart. They will work a bit closer. Some people might half meter. I always like to say 1 meter gives maximum cooling, but you can mount them a little bit closer. It's not a problem. Don't put them right next to each other. You can see behind me, they're actually mounted half meter, which is fine. If the place is reasonably cool, not a problem. If you're in a hotter environment, then you need to mount it further. The fans themselves will only run when the inverter is hot, or you're in a hot environment. If you mount it inside and you've got air conditioning in your house, the fans won't run. They won't run at all. They'll be silent. People often ask this question. So you must consider mounting them 1 meter apart. Right, okay. Now you've mounted the inverter on the wall with all the correct trunking and everything is good. Let's look at the batteries. Finally, you're ready to connect the batteries. Well, obviously you have to decide what type of battery you've got, whether you're going to be using AGM, lithium, and lithium with communication, lithium without communication, depending on the type of battery. Let's look at AGM first of all. AGM is a lead acid, a wet cell. Even though they're often they contain gels, they're still considered a wet cell. It's a very old technology. So with AGMs, we put on the instruction manual a C rating of 0.2. For safe thing, you need to look at C rating of 0.1. If you can keep the C rating at 0.1, that's the maximum charge and discharge you can take the battery, then you're pretty safe. The other thing is, if you're using AGM, make sure you keep everything on voltages. It's very difficult to give an accurate SOC, state of charge, on a battery. So the other batteries, of course, are lithium. Lithium a little bit better, well, a lot better in one respect, is especially with lithium with communications, because the lithium has a BMS, a battery management system, and that battery management system can talk to the inverter and they can say, hey, look, my battery condition is this, and it's far more accurate because it's tuned for those particular cells, and it gives a much more accurate thing. So first of all, you obviously need to connect the batteries together. Make sure you have a suitable isolation device between each inverter and each array of batteries. Make sure you're suitable overload protector, a fuse, an isolator, because batteries can deliver an awful lot of current, especially, for example, AGMs. You know, you're talking about 200 ampere hour AGM. That one battery could probably deliver 20,000 amps. It could probably fry a sheet of metal. So be very careful. Be very careful when using these things. And if you know, so you must have a suitable protection device. Always recommend, and that would go into according to with the rating. You choose that you're engineers, and so you know what you're looking for. Make sure the fuse is a good quality, because you don't want the fuse heating up, and you don't want the fuse rating too close to the actual current draw that you're going to need to be pulling. So it's very, very important. It's very important. So looking to wire your batteries. One of the things that you need to consider when you're wiring, for example, it's very easy to fall into a false sense of security, especially with lithium battery, because they pre-connect, connect. They're often wired on a 35mm cable. What I was saying is, when you're wiring the batteries in, make sure your rating is correct on your cable. So generally, to an 8 kilowatt inverter or a 9 or 10 kilowatt, you want 50mm cable per inverter from the bus bar. If you've got several inverters in parallel, then you need to make sure that each inverter is on its own 50mm cable. Also make sure the cable's the same length. You don't want different length cables, because that will give you lots of problems. If you're using lithium battery, the other thing about lithium battery is you have to have a communication. So the communication connects onto the inverter, and it communicates to the battery, where the battery can give it the SOC, the state of charge, and it will also set its parameters up. So you simply do that. There's different batteries have different communication methods, but the Sunsynk provides both for a CAN, an RS485 and an RS232. And depending on the type of battery and the configuration of the battery, will be one of them. Some lithium batteries don't have communications, and if that's the case, you generally treat them like an AGM, but you must know the exact settings of the battery. Take the cable, plug it into the master, because you have a master battery, so the first battery, and then they have the slaves. The batteries have a set of dip switches on, and please refer to the battery instructions. You set the dip switches, and then you plug it into the inverter. You'll know if the batteries are talking to the inverter if you go onto the screen, which is the LIBMS, and it will show you on the screen. If you've got 3 batteries, it should have the cumulative total of the 3 batteries showing there, and it will show the C rating of the 3 batteries together, and it will show the capacity of the battery. So you need to check that. If it's not showing on that screen, then you've got a communication problem. The battery will appear to work, but it was a problem. The bigger problem also, if batteries go very low and to the shutdown level, very difficult to sometimes to restart a lithium battery, because once it's cut off, so you must make sure the settings are correct. Generally, as I say, if it's got a BMS and the BMS is communicating, it will do automatically, so you don't have to do anything. Just plug play, as long as you know the settings. If your battery is not communicating with the inverter, then it won't show any information on the LBMS page. Common problem is the cable. Always use the cable that come with it, but sometimes make sure you haven't got the cable backwards. So one will start inverter, one is battery. If it's fitted backwards, it won't work, or you put in the wrong socket, it won't work, or if you've got the wrong dip switches, it won't work. If unsure, you need to refer back to the battery manufacturer. They should be able to help you, but be very careful. First, look at the cable, make sure the cable is communicating, because if it's not communicating, it's not going to charge properly, and your SOC on the front screen of the inverter will read wrong. So be very careful at that point. So you have to be careful on the settings. So okay, batteries, as I say, they're pretty okay. Make sure if you're using a battery that's not covered by our instruction manual, you can always check with our support team to see if we've got an upgrade or if the inverter's been upgraded to match it. We work with most batteries, Dynas, Pylon Tech, UZ Energy. We work with Freedom One, Solar MD. There's many batteries that we work with. Backbone. Can't remember them all, but there's quite a lot of various batteries we work with. So most major brands, it will function, and we'll have the code to support it. If it's not there, then contact us. There are some issues on some batteries, and some respond better than others. So that's basically it on the battery. So let me move on. Okay, AC connection. Right, now we're getting somewhere. You're connecting to the mains. Well, it depends whether you're going to be operating your system in an island mode or you're going to be operating in on a grid mode. So remember, the grid connection is both an input and an output connection. So you have to remember the grid is both in and out. So you connect your grid to your grid, and then you connect your load, which is your essential load. So the grid side is, you've got your CT coil, etc. So your grid side is your non-essential, and your load side is your essential load. I've mentioned that before, and in fact on the manual it just sort of shows you an overview of how everything connects. Make sure you've got suitable protection devices. Again, on the AC coming in, I prefer to add an RCD, residual current device, your choice. And I think generally most countries it's mandatory, and also on the output you have an RCD device. So these things are very, very important. One thing to remember, if you're installing a system without batteries, you can often install without batteries. So you don't have to have battery. The inverter will operate as a grid-tied inverter. So you no need to connect to the grid in and the load out. It's just one connection. You can still put your CT coil on to limit export, but it will actually work as a grid-tied inverter. So for goodness sake, I've had people connecting one in and one out. You don't. It's one connection. One connection. Don't use the in and out. It's a single connection, and it works fine. And it will just perform exactly like a normal on-grid inverter. So we've done that to death. Right. Let's continue. CT coils. This is what upsets and confuses everybody. CT coil is a current transformer. This is the device that stops the backflow of the power. So it's so important. I've done other videos on it, and there's some on the blog, and try to explain a little bit more. But the CT coil, there's the CT coil's internal, the inverter has built-in CT coil, but we have one external. The external one basically goes by the grid, the supply in, or it must be mounted using a generator before the generator. Don't mount it on the grid and don't mount one on the generator. We have people not mounted on the generator, and it's power flowing back into the generator. It'll burn the alternator out in the generator. CT coil for our inverters are 1 to 2,000, as mentioned on the training manual. So if you have to get a bigger one, because some cables are bigger, especially if you've got lots and lots in parallel and you've got huge feed in, our coil won't go over the cable coming in. So you have to get a bigger CT coil than the one that's supplied. So you're just looking for a 1 to 2,000 ratio. CT coil, these are pretty standard technology. It has two connections. You'll see a K and a 1 or an L. Some of them are L, some as 1. So you see two connections. You see an arrow on the CT coil, which is the flow of the power. So the power flowing from the grid in is the flow. Make sure you mount it the correct way around. It's very, very important to mount it the correct way. I've just showed you an example on the documents. There's two wires. Some of them don't have wires. Some of them are basically just terminals. You have to put your own wire. But our one comes with two wires. It's a black and a white wire. So you can see the white is positive. So the white is your positive connection, your black is your neutral. Different inverters connect differently. I've shown on the training manual where you'll see like 5 and 6 on the 8 kilowatt where it goes into. So the 5 being positive. There are on the other inverters a slightly different connection. So just refer back to the user manual to show the connections. CT coil is so important. It is really, really important. One thing to check, if you check on there's another screen. So if you, when I was explaining before, you have a screen that show, like you can see on the training manual, that is more of a text screen rather than a graphical screen. If you look on there, you will see that if you'll see that the CT wattage, that's the CT coil you connect to, if that is a negative, generally means you put the CT coil in backwards. It will cause loads of problems. If you don't fit the CT coil, loads of problems. So we get people with, I can tell you how many people fit the thing backwards and come on and say, oh, it doesn't work, doesn't do this, it's showing wrong readings. It will do, it'll be all messed up. You must fit the CT coil in the correct way. I can't tell you how important it is. And it is often cause confusion. Another thing is how long can you put the CT coil, because you might have the inverter one end, because the inverter wants to be close to the batteries, because batteries are low voltage, high currents, it needs to be fairly close. Normally CT coil, 10, 20 meters, twisted cable, it's a twisted type, works best. If you go longer, it may work, but you've got to be careful because it can be prone to interference. So you don't have it too long. And it's one CT coil per master. So that's it. Just be careful. Just be very careful. It's just so important. People see it in the box. What's this? Well, it won't work. The system won't work without it. It controls the exports. It controls everything. And especially if you're wiring it correctly, so you're using your essentials on your grid and your non-essentials on your load, your solar will still power your essentials on the grid side. Still powers both sides because it flows out of the inverter, and then the CT coil say, hey, stop, don't go past here. And so if your load on the non-essentials is not very high, then the inverter won't deliver much power on that side of it. If the load is on the other side, it will deliver more power. It totally controls the power. So it's very, very important. And this is one of the special things about the Sunsynk. So be very careful. If you're unsure, there is some more information listed onto our website, sunsynk.com, and I've done a short blog where I just show the CT coil in a little bit more detail. So have a look at that and also refer back to the instruction manual. Okay, let's move on. MPPTs, maximum peak power trackers. There's two of them on most of our inverters. Some of them have got one, but most of them have got two. Two types. We use one type which is a higher power and one is a lower power. The main reason we use MPPTs rather than PWM, pulse width modulation, so the old-fashioned type, and a lot of the cheaper ones are PWM. They may call themselves MPPT, but they're actually in fact PWMs. A very simple example is if you're using, say for example, 100 watts solar panel, 4 amp, 24 volt, and you try to charge a 12 volt battery. So you put your 100 watt panel to charge a 12 volt battery, 24 volt, yeah, charge fine. But simple mathematics, the panel delivers 4 amps. You put 4 amps on a 12 volt, it's only 48 watt. Where's the other 48 watts gone? Into oblivion. That's why MPPTs are so important, because you're clamping the panel down to a lower voltage, but the current remains constant. So by using the MPPT, it maximizes the performance of the panel and you get the most power out of the panel. Solar panels are a little bit strange animals, and so therefore you want to connect it, you want to optimize the facility. There's two, also remember, you have your VOC, which is your voltage open circuit. It's very important, very, very important with our inverters. And with a lot of inverters, it's important. And I'll explain a little bit more about why VOC. So some of the inverters, some of our inverters, you can wire 2 strings on one MPPT, some as a single string. Most important thing, the king, never let the VOC exceed over 450 volts. If it exceeds over that voltage, you can, and you probably will damage the inverter. High voltages damage the inverter. It's not a current thing, so it's quite difficult to protect against, but voltages can damage it because it has a DC to DC converter on it. You know, when you're connecting your solar panel, 2 things: check with the solar panel manufacturer what the VOC is, and then multiply it by the amount of panels. Another check is check with your multimeter. And you can also do another check. You can count the cells. So you can count the cells in each of the wafer. Generally, it's 0.6. It's not always 0.6, but generally it's a 0.6. If you count the number of cells, individual cells, and then you multiply it by 0.6 volt, will give you the VOC voltage of the panel, and then multiply it by the size of the array. But just be very careful. VOC is king. It's not the wattage of the panel. It's not the current of the panel, it's the voltage open circuit, the VOC. I can't emphasize that enough. So if you've got, say, 12 panels, Wire, and you've got the large MPPT, put in 6 on a single MPPT, wire 2 lots of 6 onto one channel. Do not wire them in series. So if you use a combiner box, you can use the combiner box separately, so you don't necessarily have to use the inverter, so you can use separate combiner box, but it is important. The absolute maximum is 500 volt, but we always say 450, and it allows a little bit of tolerance. Also remember cold weather. If you're going to install in the United Kingdom, for example, it's cold, it's nice and cold, and we often hit below zero, the peak voltages can rise, because the lower the temperature of the cell, the higher the VOC. It does rise a little bit. And so again, you must be very careful, otherwise you'll blow the MPPT, the DC to DC converter on the MPPT to bits. On our inverters, it's either done by MC4 connection, so the smaller ones are MC4 connection at the bottom of the unit. The larger ones, we have a crimp, and you take the cables in and you make it off onto the panel. So you can see there's two types. Either way, just also be careful with polarity. Make sure you polarity. There is some protection, but when you're pumping thousands of watts into it, just be careful, polarity, always check polarity. And the same way your batteries, for goodness sake, be careful of polarity, because if you're going to connect a massive amount of current, you will blow the thing to pieces. You be careful. And that's why fusing is good, the correct size fusing on everything, and also fusing on solar panels. You know, it is a mandatory requirement on a lot of things to actually have fusing on solar panels. Okay, right. What I've been talking about is pretty basic stuff, and I'm sure most people know about it. And I'm presuming that most people watching this video are electrical engineers. So you've installed it, you've wired it, you're going to switch it on. Don't switch the grid, don't switch the load on. So leave the load off at this point. Switch it on. You're going to go to commissioning. You switch it on. You have to press the button, because it will light up when there's power going into it. It lights up, and a lot of people think, oh, but the inverter won't run. Click the button. It might be on the side, underneath. Click it on. I have to confess, I have done it. I personally have actually installed an inverter. Oh my God, what's gone wrong? Why is it not working? I forgot to switch it on. So if I can do it, anybody can do it. It's a simple thing. Turn it on, turn your DC or your solar array on, click, click, and you're on. Look at the screen. I'm not going to go through all the screens in this training, but the front screen, I love the front screen. It was designed originally because we were doing a lot of work on boats, and I actually love the way it clearly shows the amount of power generated in and the amount of power out. It's very useful, especially if you're on islanding or standalone systems with no AC. You want to see what's being generated in, what you're going to use. And you can always say to your client, you know, don't use more than you're generating, because, you know, it won't work. It'll crash out. I've had to explain that to many people, especially on boats. They say, well, in the middle of the night, the power goes. Yes, because, you know, your energies come from the sun. And if you haven't got enough energy off the sun, then it won't charge. They say, but it works in the morning. Yeah, because the sun's shining. So always look in and out. And I love that chart. We actually have the dials at the right-hand side. The dials are real time. So the chart is an accumulative. The dials are real time. So you've got the best of both. You can see exactly what's going on at any one time, and you can see the cumulative. We also show the state of charge of the battery, which is, I think, is quite important. We show generator runtime. We can't measure the current from a generator, because the generator can be configured in many different ways. And it can be configured just to charge the battery, maybe use another inverter or inverters, made lots and lots of ways. So all we do is show the generator runtime, and at least you can see at a glance, oh, the generator's been running for an hour today or 2 hours. And if you're using an off-grid solutions, or you might be using it as power saver, then the generator on time is very important, because you might only want it to run 2 or 3 hours a day. You don't want it running all the day and use all your diesel up. So that's quite important. We do show you what, if you're drawing power from the grid, your cumulative, what you bought for the day and what you sold for the day. There are charts by clicking through, and you can see the whole historic charts. So if you want to see the source of history, if you click on the various dials, so if you click on the number 3, then you will come onto the solar history part, and it'll give you all the history, daily, monthly, yearly, everything, and the charts. It's all there. If you want to look at the sort of grid history, if you click on the number 8, the bottom right-hand corner, and then you'll see the grid history if you use grid and what's going on. So you've also got, you can also click on number 5, which is, and it says mark number 5 in the book, which is actually the bottom, the dial at the bottom left side, so it's in the middle, towards the middle. That one will give you sort of like a matrix. It's an alternative to the front page. It just, rather than have it graphical, it has everything sort of laid out, maybe easier. I personally like the graphical approach, but if you don't like the graphical approach, you just do numbers. If you click that, you've now got the numbers and just a bit more boring, but it's all there, and it gives you maybe a little bit more information. So it separates the MPPTs, so you see MPPT 1 and 2, and that way you can see if you've got any shadowing or you've got any issues, so it's a little bit clearer there. If you get from this page, it does navigate through everything. So the little cog at the top is your navigation. If you click that, that then will take you to your programming page. The one thing that I mentioned earlier on, if you click the bar chart, it actually comes, and you can see on this menu, it comes to this system flow. I love the system flow. The system flow shows you exactly what's going on. It shows you the power of the MPPTs. It shows you what you're doing with the power. If you prioritize the load, if you take the battery, you safely charge your battery, what's coming from the grid, what relays are open, what relays are closed, the direction of the flow, everything is there. It's absolutely unique to something. Look at that. It's a great thing. It's a great diagnostic tool, because if you want to know what's going on, click on that and you can see instantly what's going on. So it is a very useful diagnostic tool, because, you know, sometimes you might have a large array and you say, well, my array is not generating, you know, I've got a massive array, but it's not generating any power. Well, if you're not using the power, it won't generate it. So you've got to use it. You've got to charge your batteries, or you've got to be using it. But if you're not using the power, there's nothing for it to go, because, you know, where's it going to go to? Is it just going to go? You can't. It needs to complete a circuit. So if you've got a 10 kilowatt array and your batteries are full and you're only using 3 kilowatt array, your array is only going to be a 3 kilowatt array. It can't be a 10 kilowatt array because you ain't using the power. So one of the other things we've got is we call an auxiliary load. So if you're in that position and you're lucky, you've got more power than you need, you might choose automatically to switch the inverter to an auxiliary load. And that could be a water geyser, a water heater. It could be in a big air conditioning. It could be whatever. If you're in a wind turbine, so if you might use one of the MPPTs to be controlling the wind turbine, and often this can happen because the wind turbine, you've got a windy day, it's generating. You might use the auxiliary to. They might refer to it as a dump load, and it will go to your water heater. Basically, that's putting a really big load onto it, and it's slowing down the wind turbine. So it's something to bear in mind. I'll talk about wind turbines a little bit later on. Okay, programming. So if you go onto the little cog at the top, you've got your sort of programming page, which is your basic, your battery, your grid. I've got loads and loads of stuff on the internet to see how to do that. I'm not going to go too much about the programming of the unit, but presuming everybody's got some basic ideas and you set your batteries up and stuff. But what I will do is I'm going to talk about modes of operation, types of different ways you can operate it. The most important thing about the unit is your system mode. So you've got your system mode, which basically controls the product. It controls what's going on. And in fact, that's the icon, is the end top icon, which is system mode. The other icons are fairly basic. You know, you've got your basic, which is you want to put your name on the front, or if you're brave enough, as I said before, your phone number, your battery setup, which I mentioned about battery, and setting up your BMS, I've covered it, your grid, your frequencies, and again, the grid, you know, these things may be useful if you've got faults and stuff, fault finding. Advanced settings, if you're going to multi-inverter, parallel inverter, you've got various options there. You've got your auxiliary load, which can be used for auxiliary. Is also it's a load. It's also used for generators. It's also used for microinverter. It's used for load shedding. It's got loads and loads of things. Fault codes. Fault code is a diagnostic tool, and I'll talk about that a little bit later, so it's very important. Let us go through and talk about modes of operation. Understanding the Sunsynk machine. Well, if you can understand the system controller, you will know what it's all about. I'm presuming that you follow how the battery works, how to set up a grid, how to set up the other parameters. So the most important thing is the system mode. This is the control. This is the heart. This is the thing that tells it what to do. And it also what makes the Sunsynk quite unique. This is a bit like the timer of a water geyser or a central heating system or whatever, depends where you live. So this is, you need to get your head around it. You need to fully understand how this works. And if you can appreciate this point, you will understand it. If you're new to Sunsynk, what I would suggest is you get one of the machines, you wire it, you just need to connect to the grid, just put a plug top, as the Australians call it, a suicide lead. So you get a cable with a plug, connect it to the grid connection. You don't need to connect anything else. Just make sure it's safe, make sure it's correctly grounded, and then you plug it in and you can leave it on the desk or your bench. And you can look at it. You can look at the screens, and it will show you the screens, and you can start to appreciate what it can do. And just familiarize yourself. Don't get to a client's place and not be familiar. Make sure you're fully familiar with the system, how it functions. So, system mode. First of all, you have a box, lots of boxes that says time, power, SOC, V, grid, gen. Wow, it looks really complicated. That's a timer. It will only work if you click timer, use timer. I'll explain how that works in a second. Let me go through the other boxes. The other one is priority to load. I was mentioning earlier on about when the sun is shining, what do you want to do with that sunshine? Do you want to charge the batteries first, or do you want to supply it to your load, your essential load? Or you can, your load can be essential or non-essential, be grid side or non-grid side. So depending on how you've configured your inverter. But basically that will prioritize your solar to there. If you don't tick it, then the solar will charge the batteries first. Personally, I always prefer to charge the batteries first, especially if you then know you've got a full set of batteries at night when you've got no sun. But sometimes people do come up and complain, say, oh, well, the sun is shining, it's bright, but I'm still using energy. Why am I using energy? This is terrible. I've got a solar system and it's using power because the sun's charging the batteries first. So you choose. If you don't want to charge the batteries, you're not too bothered about charging the batteries, because some people might use, for example, the batteries as a reservoir. So first of all, they want to use the power. And if they've got any left, rather than lose it in the abyss, they'll dump it in the batteries and they'll use it at nighttime. So you've got sun at night, the midnight sun, as some people call it. So look at the other sorts of boxes that you can tick. Number one, it's marked on the, you'll see on the training manual, it's marked as 1, which is 0 export. That basically, it means it doesn't export any power. Uses CT coil to block the power, and it will not export anything. So if you set it there, it will not export. The next one is your solar export. If you want to export it, you can click and you can export solar. So it basically allows you to export the sun if you want to, and you can do that. So there's an option. And then the third one there in the array is limit power to load. So basically you have your you've got your grid connection, you've got your load, and you've got your auxiliary. It will basically limit all the energy to the load, which is your essential load most places. So you've got the choice. Then going further, you've got 0 export power. Now, I did try to explain, in some countries, you might have prepaid meters. You're going to connect it to a prepaid meter. If you try to export past the meter to basically turn the meter back, it will trip. It won't work. And some of these meters are pretty sensitive. So what we have to do is we have to allow a small amount of power to flow through from the grid into the system. And by allowing a small power, then that makes it less sensitive. If you have 0, then you're always going to get a voltage there, and it can trip. It's very low. So often we set that to 100 watts. It's very little. So you'll set your 0 export power to, say, 100 watts, and it's more for prepaid meters. Maximum cell power is a little bit confusing. This is actually the power of the inverter. So this is your maximum power. Now, some countries have a limitation on the size of the inverter you're allowed, and you might have to set it to 3.5, 3.65, depending where you are in the world. But this is the maximum power. In some circumstances, this might be prefixed by us because it may be only allowable in certain countries. There's a limitation, and we have to preset the limitation. So this is something that we can preset, or you can set it yourself, and it can be obviously locked. Going through the rest of the system mode, we're using the timer. Well, obviously time is real time, when it will do something. You've set the time on the clock, and this will say when it will do. Power is the amount of power it will do it with. So basically, if you set it to sort of time 12 o'clock and you put 2 kilowatt, and you then say the next thing is SOC, is an if. if the battery voltage is below, if you're charging below that percentage, it will charge. And if you click grid, it will charge from the grid, it will charge from the generator. If you don't click it, it will discharge. So you've got three states. You've either charged grid, which is the grid coming in, gen, which is the auxiliary port, or don't click, it will discharge to that level. So if you say SOC 100% and you put the time at 2 kilowatt, it will discharge 2 kilowatt until the battery reaches 100% at that time. It will continue to do that until you tell it something else and set another time. So basically, don't put a single line time, because then it will just click at that thing and it will never do anything else. So you set your times and you do your different times, and tell it what to do. It will only use timer if you click timer. It takes a little bit of understanding, and I'll go through some of the modes of operation, and then we can look at the sort of the system mode in the various modes of operation. So, okay, simple one. UK, I'll mention the UK. On grid, no PV photovoltaic cells, because in England we have a slight technical problem. We ain't got any sunshine. So now, then you probably gather I'm from the UK, and we normally have a joke. He said, well, summer's going to be turning up on maybe August 23rd, 24th, you know, whatever, maybe the afternoon, that's summer. And it's finished. We get plenty of rain in the UK, but not much sunshine. I think the UK generally has a sunshine rating of 1. Maybe in the southern areas, we might get 2. And in northern Scotland, we might get 0.5. Bugger all. And unfortunately, you know, compared to, say, people in Australia or South Africa, and you guys are lucky, you got plenty of sun. I live in Hong Kong. We have about 4 to 5 sun hours. Technically, this says 5, but I can tell you some days we'll get 1, and some days we'll get 8. So it's very erratic. It's not a nice steady. And I've actually seen some of the figures in South Africa, and it's pretty steady eddy. It's pretty steady 5 I've seen with data loggers used on sites, and it's pretty steady 5 kilowatt. And I think you guys are quite lucky. You do tend to get a lot. I know some overcast days when I've traveled in South Africa. I've seen plenty of rain and plenty of dull days, but generally you're pretty good. So basically, setting up as a PV, you're programming. You set your basic setup, which is your language times 8. Your battery setup. Make sure you've got good communications. Set your grid parameters up. Auxiliary load at this point, no need to touch. Check your lithium batteries communicating, and then go to your system mode. And then your system mode, I've given you an example. So basically, at say 12 o'clock 24, you will want it to charge from the grid. You don't want it to export. And at 6 o'clock, you want it to operate up until it gives. So you're working in reverse. Basically, you're charging at night, you're discharging at daytime, because often electricity is cheaper at night in many countries. Main reason, for example, in the United Kingdom is there's no power. The power stations don't need to power anything at night, and the turbines are whizzing round, and they've got nothing to do. Other countries, maybe in Australia, this may happen during the daytime, because everyone's on PV, and the turbines, the generators, have got nothing to do. So they may. I'm not sure these options are available yet, but I'm sure it will come about. For example, in Australia, they will probably treat peak time as daytime, whereas off-peak as daytime, whereas UK off-peak is definitely nighttime. So you would use the timer as a very simple setting. So you're basically charging the batteries at night, discharging during the daytime, AC coupled. So if you take peak, it doesn't matter if you only got 3.5 kilowatt. And you're only powering it all through the one connection. So you don't limit your power to load, you power it through the one connection. And of course, your maximum cell power is the limitation of the inverter. Okay, moving on. You might want a UPS. So UPS, uninterruptible power supply. This is more for sort of maybe for a hospital or stuff where you've got a good supply, but occasionally you may have a power outage. The great thing about using the inverters, multi-inverter or single inverters, UPS, is unlike a generator's got start, and you get some places that generator might be used for maybe years. Suddenly, power outage, generator comes to go on, it won't start. It just won't work. Whereas the nice thing about the inverter, it's working, it's checking its batteries, it's monitoring everything. Especially got lithium, it's got very long life. Everything's being checked. And you can even let it cycle a little bit, the batteries. So nice thing about it is you don't want to get some batteries they used to call on nickel metal hydride memory effect. It doesn't so much happen on lithium, but maybe a good idea if you're using on UPS, let it cycle every night. Just drop it down a little bit, bring it up a bit of a cycle. I know it's probably a good thing to do, but you want to make sure you've got maximum power when you need it. So your programming is basically your basic setup, your battery, your grid, your auxiliary load. But this time you're going to take your power from the load, so you're going to limit your power to your load. So it's a very simple thing. You don't need to set your timer. You're not going to use a timer now, because basically if you basically, unless you want to cycle your battery, if you want to cycle your battery a little bit, use the timer. If not, it's just a pure UPS. You can do it this way. It's very useful. Computer. What you might consider on this type of application is use two inverters. So one inverter is charging the battery and one is discharging. So if you're in a very susceptible area where you've got a lot of power outages and you're running, say, a big computer, a mainframe, and you want that completely steady and never go off, then you might choose to use one inverter to charge the battery, one to discharge the battery, because when it changes over, when the UPS cuts in, it's done by a contactor click over, and you get a microsecond delay. Mightn't affect anything, and it will keep within the frequency, so everything will lock on. But sometimes, depending on how sensitive your equipment is, it could affect it. Chances are it won't, but it could. So you have the option of using one inverter as a charger, one inverter as a discharger, just an option. But generally, most UPS don't need it. And in fact, for most applications, you might see a slight flick on an LED light as it changes over. It's very, very fast. It's really fast. So, okay, using a generator. Right, so this is interesting. You have to obviously tell and likewise also when we talk about UPS, you have to point out to charge the battery from the grid or from the generator. You have to tell it. You go on the box under the battery setup. So you have to use the battery setup box to change it. Now you'll see I've given an example and you can look at on the page. The auxiliary load, use it as a generator input. Make sure you tick it. Make sure you tick charge. Make sure you tick the rated charge. You've got to put all of that on. I'm presuming all your batteries communicating and you've set up as an AGM or lithium, whatever battery you've got. So you set up all of that side of it. So once you've done that, it's fairly basic and it's fairly straightforward. Using a generator, if you're using on multi-inverter, then you'd be better running the generator from the grid input. One thing you have to bear in mind about a generator is, and this is always something that causes a problem sometimes, is when it's running from the grid input, that generator has to power both the load, the essential, non-essential, so it might be before the inverter, after the inverter, and charge the batteries. So that generator's got to do everything. So if you're using it, so generally the generator it's got to be big enough. So if you've got an 8 kilowatt load, and you want to charge your batteries, then you need something like a 12 kilowatt or 12 kVA generator set to make sure it can power everything. If you've got some non-essentials before the inverter, and you might have quite a bit of non-essentials and essentials, so that will be connected before the inverter, don't forget to connect the CT coil before the generator, and you then connect your non-essentials. Essentials, you might need 20 kVA or 30 kVA. Depending, so the inverter is your UPS part, which is your essentials. And it's also going to charge the battery. What we've had experience is people use too small a generator, and the generator clicks over, and suddenly the generator slows right down. Frequency goes to pot, inverter shuts down, whole system, and oh my God, this is terrible. And then they try it again, and the same thing happens again. Same thing happens again. We have the battery charging circuit steps up, so we don't hit it. We don't hit the generator with the battery charger. So the slowing down is generally coming from the load. Once the generator's taken the load, essential, non-essential, then the inverter will start to switch in the charger. Now, if on an 8 kilowatt, we have a maximum pass-through current of 12 kilowatt. So if you're drawing a full 8 kilowatt, then the inverter will allow will allow some of the power into the battery. And a simple thing is it will bypass the current. So you're up to 12, so it'll allow 4 into the battery, because the inverter will be operating backwards. So some of the power will go into the battery and the rest will be basically bypassing it. So the maximum power on the inverter allowable is 12 kilowatt on an 8 kilowatt inverter. So it's really a 12 kilowatt bypass. That's for your essentials. Your non-essentials, you can put what you like on, as long as you've got your CT coil. So you've got to remember that. If your battery then needs more charge, and you're trying to set your charge for a higher current, it won't charge. If you're passing full currents with the inverter, then the currents of the battery will be less. If there's less current from the inverter, then the currents, because it just protects itself. It's pretty obvious if you think about it. If you want to use a generator on a multi-inverter, again, you've got the same thing. We do have a gen input. So a single inverter, you can quite often use the gen input, which is fine. And you can select the gen input and you can connect it and it will switch. But again, via the gen input, it's limited 12 kilowatt on a single inverter. And you can only really use the gen input on one inverter. You can't use it on multi-inverter. So if you're using a gen input on a single inverter, it will switch to the gen input, but the gen input will then, we call it auxiliary, and it's provided you've selected it. It will then take the full load. So the full load is coming, if you look at the relay configuration, gen, load, battery charge. So, and you can see on the system flow how it's functioning. You can, if you're using multi-inverter, as I say, you must connect on the grid side and use a suitable changeover. If you've got grid and no grid, use either an automatic or a manual changeover. You can click it over to generator. Make sure your CT coil is connected in the correct place. Don't put the CT coil after the generator, otherwise you'll burn your generator out, because the inverter will start trying to export. Because it's not really exporting, it's considering the house. And if your CT coil is not fitted, or it's fitted in the wrong place, then your generator can damage. So be very, very careful on that. These are sort of basic points. What I was trying to explain before, if you've got, say, 4 inverter system, you may choose to put 3 of them in parallel and a single one of them as a charger circuit. You can connect your solar panels to all of them, but one of them is a dedicated charger. And the nice thing about that, if you're using a smaller generator, so for example, I've got a 10 kVA generator, but I've got a 30 kVA load, and I only want the generator just to top up a little bit, then the generator is not having to supply the whole load. All the generator is doing is charging the batteries. So one of the inverters would be a dedicated battery charger, all the batteries in parallel, and that would just charge the batteries when the batteries reach a certain point. That inverter can turn the generator on. That inverter will bring the batteries back up if need to a certain level, but it's not going to put too much stress on the generator. So by doing that, it's an alternative way of doing it, using 2 inverters. Some people using maybe a smaller inverter as a charger, a secondary inverter, say 5 kilowatts charger, and 8 kilowatts as a load. So you might, good example, maybe 2 8 kilowatt, or 8.8, actually 9 kilowatt. In fact, nowadays we're actually going to rate it up to 10 kilowatts soon. So you might have 2 inverters paralleling to supply your load, and you might have a small inverter as a charger operating purely as a dedicated charger, and you might have a small generator. That type of system works beautifully. And the nice thing is no interruption. So, the other thing is you've got your grid coming in, your non-essential on your grid, your essential loads on your load side, on the inverters, they operate perfectly well. The charger works independently and nothing clashes and nothing's going to burn out. It works great. So it's something to bear in mind. So yeah. Okay, let's continue, and you'll see on the documents I've tried to cover lots of different things. There are lots of ways and there's lots of configurations. I don't really want to go through all the variants of using the inverter. So there's lots of different options to use it. And let's look at something else. Let's look at let's talk about earth bonding. Right. People always fall foul of earth bonding. RCDs. Well, they've come a long way from when I was at college. An RCD was a Wheatstone bridge. And of course, an imbalance would be purely a mechanical device, totally mechanical. And the idea is power comes out the generator, typically is 3-phase, goes into a transformer, it is produced in a delta format, goes to transformer, produced in star format. Essentially, the star then becomes your neutral or your earth, it's driven into the ground. Then if you touch one of the phases, you're going to get an electric shock. It can kill you. So the RCD, or we used to call them ELCB, earth leakage circuit breaker, and nowadays they're called residual current devices. That's the device that stops you getting killed. So if you touch it, it allows 30 milliamps, for example, to go through your body and then clicks out. So these are mandatory. First of all, make sure you earth. First thing, make sure you earth your inverter. You use earth rod, or you've got a good grounding to the incoming supply. So make sure the thing is earthed. RCDs. I have given a recommendation, type A, 30 milliamp, curve code, type C. I'm not going to explain all about that, but there is a recommendation for the type of RCD. Again, your country may be slightly different, so you may choose as an electrical engineer to use a different type, but this is just purely a recommendation. It's not necessarily a mandatory thing. Earth bonding. Now, this is an interesting thing. Are inverters different? Yeah, because it's both an on-grid and an off-grid inverter. It can work in islanding mode, it not. It's different to, say for example, because it's an AC coupled inverter, and it's also an off-grid inverter, it's one of the same thing. It will function differently to other inverters. So some inverters, you can link all the neutrals together to the ground. Now I know in many countries they allow you to do a neutral bond to the ground. But if you've got a neutral bond to the ground, your incoming RCD will trip. Simple as, will trip because it's getting imbalance, because the flow coming out from neutral will hit ground and you've got an imbalance and it will trip your incoming RCD every single time. Right, but you need that bond for your outgoing RCD to operate. Otherwise, your outgoing RCD can't operate, because if it hasn't got one of the poles to ground, it can't sense the potential difference when you touch something. So for one scenario, your outside needs the bond, but your inside doesn't. So this is a variable bond. With simple inverters, it's very simple and you can do that. But with our inverter, sometimes it's running on islanding mode and sometimes it's not. It's not a case of saying you've got power coming in on the grid and it's in grid mode, and it's not, because there's a time difference. So there's always a time lag. You could argue and put a relay on the grid and then the relay makes the bond, but there is a time lag and there is a time difference. Sometimes it could be 2 or 3 minutes, sometimes depending on what the inverter is doing in the mode of operation. So it's not always strictly true. So you've often got grid there, but it's still running on islanding mode. So we allow to using an earth bond relay. And if you connect to the ATS section of the inverter, it's a 240 volt switchable output. You then select this. So on the battery setup, there's a grid islanding box, and you click the box. And so basically, when the unit is in islanding mode, if you connect a 240 volt relay, it will click. Use the relay to bond the neutral strap to ground. That's it. And so when it's in islanding mode, it will strap it to ground. So you then got your complete circuit for your RCD. When it's not in islanding mode, it removes that strap because you're relying on your main RCD coming in. So it's very important. It's very important. I know some countries don't have an incoming RCD, and I don't want to go down that way, on that route, because I personally don't agree with it. I think it's not very safe. So, but I can't argue with local regulations, but that's only my personal opinion. Okay, right. Auxiliary, or we used to call it smart load. Great feature. I mentioned it earlier on in this presentation. Sun is shining, batteries are full, you're not using much power, using a kilowatt, you've got 10 kilowatt array, you're only using a kilowatt, you're on a 9 kilowatt, what are you going to do with it? Well, you can export it, probably won't get anything for it. So the thing, you can then make a setting, you can choose, if the battery's reached to 95%, you can then divert the power to another load. Could be to a water heater, could be to an air conditioner. And you, by selecting auxiliary load, you've also got the microinverter input, which is a separate thing, which I mentioned another time. But then you select the auxiliary. You see auxiliary battery on, auxiliary battery off. That's the level. So if the battery is 100%, it will switch to auxiliary. If the battery drops to 95, it will switch. The power comes from the battery and it comes from the inverter. So it allows a little bit. It doesn't come directly from the sun, otherwise it'd be switching off and on and it won't work very well. So it has the battery as the buffer, and then the solar power is the amount of power you wish to go to that load. So if you want to put 4 kilowatts to the load, and once the batteries are full, and say you might say, well, the batteries are 90%, I'll switch 4 kilowatts to the load. People do use the smart load other reasons. You can use it also backwards. So some people use it as non-essential load. So if you're an islanding system, so if you're on an island mode, and you might choose to use that as non-essential. So if your batteries are full, it'll work in non-essentials. And then when the batteries drop a bit, that will cut out. It's great if you're, it can give you sort of 2 levels. So it gives you 2 levels of, so you can work it backwards. You can use it as 2 levels. So you can have it as non-essential, essential, or you can use it for surplus power. There's loads of uses for it, depending what you use. I've seen people using it to run computers and basically servers. And if the power drops below a certain amount, it will shut down the server, the computer. If they're bit mining, I know one guy was bit mining, and they had it running, and then basically as the computers, the servers were using quite a lot of power, as the evening went on, it would shut the server down, but it would keep the essentials, so it would keep the lighting, the security, the electric fences, whatever, still running. So that's quite important. I'll give you an example there of a wiring where you might have a normal switch working a water heater, and then you have a little changeover switch when it's switched on, and then the unit, the inverter, can automatically heat the water if it's got surplus power. It's great on boats and stuff. So it's a very useful feature. On the same page, we also have what I call it power shaving. I know people call it different names. It's basically, that's me, so maybe I've got it wrong, I don't know, but I've always called it power shaving. And so we'll call it power shaving because I'm doing the presentation. Power shaving, basically, if you've got, say, I use several examples. If you've got, say, a 5 kilowatt generator and you want to draw 10 kilowatt, well, you can't. But if you put the inverter and the batteries there in front of it, if you need to run 10 kilowatt, the unit can detect the extra power and the inverter will supply the extra 5 kilowatt when required. Or if you're in a multi-system, it could be a lot of power, and it could be a factory, and you might have a limitation of 50 amps on your factory, but occasionally you may need 100 amps 3-phase. And so you'll set a configuration of inverters. When your power usage increases, it will use that. And you can then charge the battery so you keep your voltage constant. And when your demand comes up, you use the battery power to soak up your demand. I know in some countries this can be very, very expensive. Going over your limits. So power shaving can be very important. I've seen in sort of Australia and South Africa and places where they penalize you if you go over your demand. So power saving, it's a nice feature. You know, you can have a system without any solar panels, just have a few batteries or whatever, it depends on how often. If you're using a generator, it's great for generators because, you know, you might have, you might be running a small generator to power a number of porta cabins, but when you want to boil a kettle, the generator can't power it. So the inverter can power it. So it's a very useful feature. We call it power shaving, and it would be often a dedicated feature. So you just use the inverter just for a power shaving mode, and it's generally a mode of operation. So it's very useful. Okay, moving on. Wind turbines. Well, our inverter, it's been tested, and I've got some videos. Anyone's interested, we've tested with a wind turbine. You need to run it with relatively high voltage turbines. It won't work with a 12-volt turbine. There's little sort of toys. This is proper wind turbine, proper stuff, and it works great. You know, traditionally wind turbines would run on an on-grid inverter or string inverter, and it would export the power. But nowadays you don't get anything for it, so you want to save the power. So you might choose to use one of the MPPTs onto a wind turbine, say the 5 kilowatt wind turbine. Wind turbine are basically a 3-phase motor with a PM, a permanent magnet, and the magnet rotates inside, energizes the coils in a 3-phase configuration, and it goes as fast as the wind turbine is allowed to go. Many wind turbines have internal braking. Totally recommend if you're going to put a turbine, make sure it's got self-braking, it's self-regulating, because these things can produce dangerously high voltages. So you've got to make sure it's controlled. Don't rely on the inverter to brake it, because suddenly braking doesn't mean slowing it down. It must have self-braking, it must be self-regulating in the wind turbine. And if it does reach dangerously high speeds, it can completely shut it down, lock its blades. It's very important. So please don't rely. The inverter can control certain things, I explain. So the wind turbine produces a 3-phase. You've got to rectify it. You've got to put through a 3-phase bridge. So we make a little converter box. You can use our converter box, so you can build one yourself. So it's a 3-phase bridge rectifier. We use a load of big capacitors, electrolytic capacitors, smooth it out because the turbine's up and down, loads of noise. We load E-caps and make sure you've got some discharge resistors because you want to kill yourself. We have a limiting resistor because the resistor then has to simulate similar to a solar panel, and it will connect to the MPPT of the inverter. If you go into the advanced setting, you'll see there is you set a profile, because the turbine will have a profile, and look at the manufacturer's recommendation, and at a certain voltage you can pull a certain amperage off it, and so you set your profile, your tickets. You might have solar on one and wind turbine on the other, and then you can do all your settings. Wind turbines are great. They're brilliant. They're great in England, for example, because we've got plenty of wind but no sunshine. But in places where you've got wind, because it constantly produces day in, day out, nighttime, 24 hours in a lot of places, depending if you've got wind. The more professional wind turbines are mounted higher, and they will run better, and they will run correctly. We do sort of recommend don't go above 350 volts. I know the mppt will withstand 450 to 500 volts, but you need to get a little bit of tolerance, so we recommend that, and also recommend using a self-braking type wind turbine. We've tested with a company called Britwind in the United Kingdom, and it works brilliantly. But the wind turbines are a little bit expensive, but they're very good. Highly recommended it. So if you're looking for a wind turbine on installation, it's something to consider. So yeah, paralleling inverters. Well, one of the most useful things about the Sunsynk machine is its ability to parallel. I know other inverters can parallel to a certain amount, but one thing about the Sunsynk machine is Sunsynk is we can parallel in 3-phase, and we can actually produce correct phase rotation, and it's a perfect phase rotation, so it will operate motors. Other inverters, some inverters can parallel in 3-phase, but it can't produce the 3-phase rotation. They're basically 3 independent phases. Ours totally work together to produce the correct phase rotation. So paralleling. Yeah, well, first of all, you need to mount them on the wall, decide which is a master. So you always have a master and a slave configuration. That's how they work. The master will control the slave to make sure they're in synchronous. Start off with a simple single phase, for example. So if you've got 3 inverters on a single phase, then you make the center the master, 2 sides the slave. If you're running on a 3-phase configuration, then you'll make the center 2, because you're going to have to have 3 masters on 3-phase. So just remember that. When you're setting up a 3-phase system, they communicate via a cable, and you have a comms cable in between each inverter. It's a different comms cable to the battery communication. It's completely different. So you have a communication cable. There's 2 connections on each one, and both the ports are identical. So the in and out are absolutely identical. So no need to worry about mixing them up. So basically you plug one to the other. Center one is normally the master. If you're 3-phase, then your center bank, one of the center bank will be your master, and you radiate from the center outwards. And that way it reduces the limit of the cable, because it's always a problem of the communications on the cable. Okay, going forward, people always do get confused. First of all, a couple of things you need to know about. All your batteries on a parallel system or a multi-inverter system must be in parallel. You must parallel all the battery bank, all one, okay? Okay, if the inverter is working without battery, then don't use paralleling. They just work as independent inverters. No need for communication, no nothing. So no battery, no cable, no multi-inverter mode, just use as a normal inverter. They will lock to each other. So there's no back, that's very important. You need 1 CT coil per master. 3-phase, 3 CT coils. 1-phase, single phase, 1 CT coil. 1 CT coil per master, and that goes on the master, and that goes onto the incoming feed. That's very, very important to remember. The master controls the battery array. So if you're on a 3-phase, you've got 3 masters. One of those masters will control the battery array. So it's a bit confusing when you've got 3 masters, but one of the masters will control the battery array, and that master will also synchronize the other masters. So you've got 1 master which will then synchronize the other masters automatically to create 3-phase. So a 3-phase, 3 masters and a number of slaves. Single phase, 1 master and your slaves. The master on a single phase will synchronize the others. A master on the 3-phase will synchronize each individual slaves, but the masters will synchronize themselves together to create the phase rotation. The 3-phase, 3 masters will synchronize each individual slave, but the masters will synchronize themselves together to create the phase rotation. The 3-phase, 3 masters will synchronize themselves together to create the phase rotation. The 3-phase, 3 masters will synchronize each individual slave, but the masters will synchronize themselves together to create the phase rotation. you basically, even on a 3-phase or a single phase, there is only one communication path to the battery. If you're using other batteries, no need to put comms. You can work independently, and they will just work on voltages, and they will lock themselves into the other batteries anyway, so there's not a problem. Then the inverters will charge individually, so each inverter can charge it onto the array, because the master will tell it when to charge and when not to charge. So that will work fine. So you need to be aware of this. Okay. Remember, each inverter needs its own data logger. Pain in the arse sometimes, I know, but it's better that way. If you're using a SolarMan application, which is it's not our application, it's a third-party application. Loads of people use it. But if you're using a SolarMan application, the application will basically group all of the inverters together, and it will give you one figure of your total generation, your total output, or whatever. So you have to have separate data loggers, and you have to log them all into things. One thing to remember about data loggers is, I personally like GSM ones. We supply a GSM one. It has a couple of years data free. You plug it in, it works. Providing you've got GSM coverage, it works. It's very simple. I know in some countries don't have it, and I was a global GSM SIM, but I think we have some issues like in Namibia. Some countries a problem, and maybe in the outback in Australia where there's no GSM coverage, so then they prefer Wi-Fi, or where they're using a satellite communication, then you'd have to use Wi-Fi. Remember, it won't work on the 5G routers. It will only work on the lower routers. So if you're in, for example, Hong Kong, I use Hong Kong as an ultra high tech. I live in Hong Kong. I know from the UK, but I live in Hong Kong. Hong Kong is ultra fast. We can't use the latest high speed router. We have to use a slightly older tech, and it works with it. And this is the same with a lot of this type of product. Inverters must be all the same type. Don't mix inverters. Make sure they're all the same model. Don't say, well, they're all 8 kilowatt, but they must be the same model, because there are some models different. So we have some 8 kilowatts or 8.8 kilowatt, 9 kilowatt, but the models are different. So they must be all the same model. They must be all running the same operating system. And you have two pieces of main software. We have what we call firmware, and we have our operating system, the user interface, the UI, what you see, what you touch. All must be the same. The operating system, firmware, and the UI must be exactly the same. The biggest problem that people fall foul of when they're setting up parallel inverters or multi-inverter is they often get an F29 error. An F29 error is actually a problem with the communication. It means the communication is not working. It's a faulty cable. Could be just a strand broken in the cable. It's got the wrong configuration on it. It's something to do with the communication. So that is quite an important problem. Always be aware of it. If you get an F29 error when you come to switch on, it is to do with the communication, to do with the cable. One of the other things is, if you're using more than one, if you're using more than 3 inverters together, the communication, we have resistors, you have to remove the resistors. It's okay if it's a couple together, but if you're using more than 3 on a system, then you remove the resistors. That's as simple as a switch. It's a little dip switch. And you see on the training manual, you see where the switch is located. When they're both on, the resistor's in place, off, takes the resistor off. It's very simple. You can just see it on and off, and you just basically click the resistors out. So looking at sort of single configuration, in theory, you can put 16 inverters onto a single configuration, onto a single phase. In theory, if you don't need phase rotation, if you're using 3-phase and without phase rotation, then you can put 3 times 16, because they're just independent phases. So it's basically 3 single independent, but it doesn't give you phase rotation, so it won't work motors. If you try to put a motor on a configuration like that, then you're in trouble, because it will give loads and loads of problems. So that's just it to consider. So, but phase rotation, you can put 15. Without phase rotation, it doesn't matter, but it's a very important point. So in theory, up to 16 inverters, and very quick check guide, which I've listed here. Check all inverters have the same operating system, same software. Multi-inverter, you must set the parallel. You must do the settings. So first of all, every single inverter has a separate Modbus number, and you then set it to become one will become a master, and all the rest a slave. And don't forget, tick the box as parallel. Many people don't tick the box. They set everything else. So, oh my God, I forgot to tick the box. Just a simple thing. Ensure that you have good quality communication cable. Buy very good. You're going to do an expensive installation. Make sure you get good cable. Set one to be the master. Set your slaves. As I mentioned before, everyone needs their own Modbus. Every inverter needs a data logger, one CT coil on the master, all the batteries in parallel, and it's only the master that will be communicating with the battery BMS. Simple as that. And switch on. Hopefully everything is good. One thing I would suggest is make sure you update your inverters. It's always worthwhile checking to get the latest software. So especially on multi-inverter, and put your data loggers on. Don't switch your load on. Put your power on the grid. Keep them separate at that point. So they're just operating the grid. So they're not really synchronizing. They'll power up, but they're not joining together on the load side. So make sure the load side's all isolated off. So there's no connections. And contact if we do this support for you, contact CN support at globaltech-channel.com, or contact one of the WeChat or WhatsApp groups, and they'll arrange to do an upgrade and check the upgrade. There's always got the latest software. You can always just phone them. We've got service centre in Soweto. Or you can, or if it's in Australia or whatever country it is, then you can phone them and you can discuss about the upgrade and make sure you've got the latest software. It's always worthwhile because there's always some changes, and as I say, we always like to try and do it better. There's always a better way, so always consider it. Three-phase configuration is similar. 3 masters, A, B, C, phase A, B, C, red, yellow, blue, as I came when I studied electrical engineering. So you've got your 3 phases. Master A, Master B, Master C. It's the 3 phases. You're then working in a phase configuration. Your center point will be your master cluster. So you've got cluster now. So you've got a master and a couple of slaves, and then you've got the other master and a couple of slaves. Check all inverters, again the same. On your multi-inverter, you obviously select your master, whatever. Ensure you have good quality communication cable. Set the master and slaves. Basically, you've got 3 CT coils. That's the only real difference in the configuration. I've just shown you a simple drawing there on the document to look at how the best way to install it. Once over, if you are experiencing a fault, just go back and check your cable. It's probably a cable. It could be either the cable, it could be the software. You're running one of them's a rogue software. One could, check the setting, make sure every screen, because if you haven't set one of the screens, if you've got 10 inverters and one of the screens not set, then it's a problem. Now, you can actually use more. Now, we actually have sort of basically 16 or 15, depending on the configuration. But if you wanted to use more, you could put, I've seen installations now with 30 inverters, and all they do is they split the power because the currents are too high. And so you'll have a common battery array. So everything's connected on one battery. So you've got this huge battery reservoir, but the outputs, they'll have several feeds. So you'll have 2 or 3 feeds, which works fine. And if you're in a large building, you might have one feed going one way, one the other. And you've got one central bank with all your inverters and your separate fuse. And it's pretty much like separate fuse boxes and separate things going on. You don't have to put it all in as one. The nice thing about doing that is if you're on say a remote location, you could put some nice switch gear in. And if you have a problem with one of the array, you can switch it out, and you can switch them over, and you can switch the other one. So if you want to service something, if you've got a servicing time, you want to do some change, you want to do some upgrades, you can keep your power running, but you can switch in and out, and you can transfer, especially if you're using multi. So I personally, if I was going into a job and I would say wanted 30 inverters, I'd probably split them into groups, and in each group I'd have some switch gear to be able to switch them in and out to my loads. And do it that way, because very rarely you need one load that would take that much current. So there's a huge amount of current. So I would probably just do it that way. I think it's a much better way of doing it. And if it comes to service or upgrades, I can switch another inverter, switch that one off, and switch something in to take the load, and have some nice switch gear. You're electrical engineers, you know how to do that. You don't need me to do that. Right, nearly finished with this training manual. Last bit, fault codes. Right, contrary to popular belief, fault codes are there to help you. Chances are our equipment is not faulty. Our equipment goes through huge tests. When it leaves the factory, it's gone through massive amounts of tests. It's been soak tested, it's been tested in every which way it can possibly be. So take it that when you take that inverter out of the box, it is working perfectly. So there's a number of fault codes. The whole list of fault codes is listed on our instruction manual. But what I've tried to do here in this training manual is identify a number of the very common fault codes. And these are the things that you really need to be aware of. F13. This is something that may pop up if you're doing something on the inverter, really, that you shouldn't be doing. If you're actually changing, say, from battery to no battery mode, changing the parallel settings, basically it should be done offload. And if you are doing these changes, suddenly an F13 might come up and the inverter might shut down. It's protecting itself. It's changing function dramatically, which it shouldn't do. So if you do get an F13 because you've done something, just reset it, and hopefully you haven't done any damage. But it is caused by changing something hot while it's on load. So be very careful about doing these settings. What I normally suggest do is take the load off. So it's just on the grid side, it's just like plugged in basically, and it's not doing any real work. And then if you're going to do changes, so be very careful. F18 fault is an overcurrent fault. This is basically on the load side where there's too much current drawn. Some people say, well, it happens at night. I get an F18 in the middle of the night. It's probably because it's probably for some reason, maybe 2 or 3 air conditioners switched on at once. Therefore, what you need to check is separate between your essential and your non-essential loads. So I would class most of your air conditioning being non-essential, and that should be connected to the grid side. During the sunshine time, it will still be powered off the solar, like a grid-tied inverter. It won't export, but it will provide power both sides. So your essential should be your lighting, your security system, maybe some sockets, your TV. You don't want some old, big, massive air conditioner put onto your essential side, because it could, if it's overcurrent, you could take it out. And you've always got to remember that, because some of these, we've measured some of these air conditioners. Some of them have a surge current of 100 amps inrush current, especially the old-fashioned type. The newer ones are much better. The inverter type are much better, but the old ones, these big capacitor starter motors, it's almost like a short circuit. And if you get 2 or 3 of these coming out at the same time in the middle of the night, and sometimes it can happen because they're just on and off as they go, and suddenly, boom, you can get an F18 fault, and it can take out your whole system, and it will shut down the system. So suddenly you've got no power. So therefore, it is absolutely imperative that you separate between essential and non-essential, and don't take these chances. So it is a problem. If an F18 does come, you must look at your peak loading and separate some of your wiring. It's quite important. F20 is also an overcurrent, but it tends to be caused by the batteries. And F20 is because the battery can't deliver enough current. Because, you know, if you're drawing power off the inverter, it has to come from somewhere. It comes from the battery. And if the battery can't deliver, there's a problem. Often look at the C rating. AGM batteries, we look at a 0.25, 0.2. I recommend look at maybe a 0.1. Off a lithium battery, again, they are much better. They're often 0.5 on the C rating, but also consider the cables and consider the cable lengths. If you've got several inverters, make sure your battery cables are all the same length. Don't have 1 meter, 1 2 meter, 1 5 meter. They all need to be the same length, even if you just run it around everywhere. If you've got 3, 5, 4 meter, whatever, all 4 meter, all the same, because it will cause a problem. And the voltage drop on the cables will cause a problem. So you must check that. So make sure, and also make sure the cables are heavy enough. Normally, if you're running off a common bus bar to an 8.8, 50 millimeter, if it's not 35 millimeter, just make sure the cables are heavy enough. People always fall foul. If you get standard lithium batteries, they tend to come with 35 mil cable, which is fine. But if you're running it sometimes can give you into a false sense of security, because you think, oh great, I've got 200 amps, and you run them connected. You can't. And if you've got 4 of them saying I'm going to pull 200 amps, you can't pull 200 amps through a 35 mil cable. So it's a flaw. You need to run the cables separately. So you need to consider the most really you want to run off a short 35 mils, 100 amp. That's even pushing it. So you need to consider that. And most lithium battery packs have that. So always check that. F23, AC current, transient current. This is what they call it. Generally, the engineers refer it to as an AC current because it can be seen the AC side. It's actually an earth leakage. It's generally caused on the solar panel side, on the PV side, not the AC side. So, but it leaks through. So it's caused through capacitors. It's something leaking through. So you need to check your solar panels. A lot of these faults do come from the solar panel array. Some poor quality solar panels, maybe tripping to the ground, There's a cable maybe leaky or whatever, there's a bad connection somewhere. So this is something to consider. You always consider this. F24, this is also an insulation impedance problem. Again, it's some sort of leaking current to the ground. You don't want leaking current to the ground because especially these panels might be putting out 200, 300, 400 volts. It can be dangerous. Make sure your panels are well grounded. If you have got leaky panel, leaking as in means leaking power, replace the panel. You have to check it. If you get sort of an F23, F24, then go with your mega. You need to check each panel, check it to the ground, check it to make sure, check your cables. You're electrical engineers, you know what to do, but it's just make sure it's basic stuff. So then they are basically all to do with solar panel. Look at the solar panel. F26 is more to do with split phase, and most of what we do, it doesn't really cause a problem. We use two phases, but if you've got an F26, I would suggest you contact the service center. It's a bit of a problem. You've got a problem somewhere, so contact that. F29, parallel communication problem. I did mention it before. It is a very, 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 very common issue. It's where people have an issue that two inverters or multi-inverters are not communicating to each other. And if they're not communicating to each other, bump, it comes up at F29. F29 comes, focus on the cable and the connections and the settings for the parallel settings. So all you want to do, concentrate on the parallel side. Either change your cables, get better quality cables, change the cable configuration, look at the resistors, which are the little dip switches you've got. Replace the cables if necessary. You don't need to contact the service center. Just do. These are things you should do automatically before seeking any help, because they'll just basically go through the same thing. Make sure all the software is the same. Make sure all the inverters are the same. The operating system is the same. Everything matches. So before you do that, do all the basics, cables, settings, check everything very carefully. Sometimes you may have 5 inverters, 6 inverters on a parallel, and one of the inverters you didn't click parallel setting, or you set the Modbus setting wrong on one of them. Just go carefully, just carefully check each of the settings on each one of them. So F35, no grid. Well, no grid presence. Well, the electrical contractor, you sort that one out. I'm not going to go into that one. F42, AC line voltage. It's basically on the inverter. If you look for on the grid parameter settings, you can set the upper and the lower settings. It depends where you're located, and sometimes some places have quite a big deviance on these, especially if you're at the end of a very long run from a cable run, or if you're on or a swirl line, for example. These voltages can be quite high up and down. You need to set them on the inverter. You've got the high grid, the low grid. Basically, this trips, and this F42 comes up if the inverter goes outside of the parameters that you set, not from the inverter, it's what you set, and go on the grid parameter settings. So if your voltage is too high or voltage too low, you can program the inverter. If it goes out the maximum permissible on the inverter, then you've got a grid problem, so you need to contact the utility. But generally, it's to do with what you set. F47, F48 is a frequency. The grids tend to be pretty okay unless you're a very small town on a very small power station, and you put a load in that causes the turbine or the generator to slow down, or you're using a generator. If you're using a generator and you load it up, you may end up with a frequency shift. Either the regulator on the generator is not working properly, it can go too high, or you load it, go too low. Occasionally, there are some frequency shifts to do with grid problems, but generally the frequency shift is the turbine, the alternator slowing down. So be it at the power station, which is highly unlikely to happen, or more likely if you're running off a local generator and it's being loaded. When they're loaded on some of the generators, they can occasionally slow down a little bit, and that's basically causing that. The grids tend not to, because if you have an imbalance on the grid, on the frequency, if one frequency is slightly different to another frequency, wow, you've got a major problem, because basically the power stations are battling against each other. There'll be battle of the power stations. So it doesn't matter whatever you do, they'll blow themselves up. It has happened. And when that's happened, it's happened in America, and it can take out the states, or in the UK, it can take out massive amounts of chunks of power when this happens, when you get a frequency problem with the power stations out, because you get battle of the power stations. It's not about your loading, it's about the power stations fighting the power stations. And it all happens, it all ends up pretty bad, and you end up with a power outage. So no need to worry about that. It's more likely to cause by a generator, or if you're running off a local supply, and that's where it tends to be the problem. You've got some settings. You can do some, again, you can go on the grid parameter, you can do some setting changes in that. F56, DC bus bar low. This is your battery. Basically, it's your battery. There's another possibility. You look at your, if you go onto your system mode and look at maximum cell power, it might be set too low. So if you're setting it a little bit low, it could also cause it. But generally, it's to do with your battery, the C rating, the maximum power of the battery. If you want to draw 8,000 watts or 16,000 watts or whatever it is, those batteries have got to be able to supply it. And those batteries have to be as good as the inverter is. And if the battery is not as good as the inverter, the battery is going to fall down and you've got a problem. So that's something you need to be aware of. F63, arc problem. It's something, it just basically means that the connections on the solar panel are not very good, and it's creating some noise. They call it an arc. I think it's more of an Americanism. Don't worry too much about it. If you are using it and it does come up, check your connections. It is a potential fire hazard. You really don't want a bad connection. It'll be a localized, maybe on an MC4, not connected properly, whatever, and it's causing some noise. So you need to investigate. It's a pain in the neck to find. It's really difficult to find if you come up with it, because you've got to check each connection. Sometimes it might be there, sometimes it might be. So in the middle of the day, when the sun's shining and the connection might bzzz, and then suddenly it welds itself and it fixes itself, because these things can fix themselves, especially on an F63 fault. So it is a real nuisance to find. And if you do get one, good luck, because it ain't an inverter problem, it's an installation problem. F64. F64 is the high temperature. The IGBTs, the insulated gate bipolar transistors, they're the things that do all the work. That's the actual engine of the inverter, the IGBTs. I mentioned before, we use IGBTs, we don't use MOSFETs. That's the thing that does it. These things get hot. These things get warm, because on a transistor you get a slight voltage drop. All transistors, the IGBTs is a sort of bipolar transistor, and you get a slight voltage drop across on the silicon, on the PNP or NPN layer, and between the two layers you get a 0.7 volt or a 0.6 volt drop, and that creates heat. And so as you pull more power, that will create more heat. The inverter has massive internal heat sinks to cool it down, and most of the time it won't even need the fan. But two things: if it is drawing maximum power and it is in a warm area, the fan will start. If the fan is clogged up and you've got dust and you haven't serviced the thing properly, then you've got an issue. You need to clean it, get your vacuum clean and clean it out. The IGBT is going to get hot. Or if you've decided to mount the inverter in a very hot environment into a container painted black, and inside it's reaching 60, 70 degrees, then as much air as you want to put across those heat sinks, it's going to get hotter and hotter, because there's no differential on the temperature. You need to make sure you've got an air conditioner. If you are experiencing that problem, then you clearly have an environmental issue. One, it could be dust, or one, it could be more to do with the temperature. You need to look at it. You may have to fit an air conditioning unit. So that's basically, I'm going to go with some common questions and answers later. But for this training manual, I've tried to sort of I've tried to cover most of the major points. So I hope I've not bored you too much. Use the document I've given you, and I will update. I will put a few more bits on later on. Thanks for watching my channel. Thank you. Bye-bye.